Hello everyone. This is the first review session for the final. We're going to go through the first several modules in this one. The later review sessions will have fewer modules since those have more content in them, and hopefully most of the things in these modules are pretty much second nature to you by now, based on the fact that you've been using these concepts to do all of the homeworks you've had since then. So the first thing we learned in this class was just MATLAB as a calculator, where basically we use it to compute numbers using many different built-in functions such as addition, subtraction, sine, cosine, log, etc., etc. So that should be pretty much second nature to you guys by now because you've been doing it all along. Some things we learned specifically in that one were a few special numbers where we had infinity, not a number, and imaginary numbers. So there's a little bit of lines of code to help review those, where we had infinity, which obviously represents numbers that are larger than MATLAB can store. Not a number is things such as dividing by 0 and whatnot. And real numbers and imaginary numbers are numbers that involve or don't involve. I guess if they're imaginary, then they involve an imaginary component, which is I, the square root of -1. So that was pretty much all we learned in the first module. We also learned about script files, which are simply a series of MATLAB commands to be executed repeatedly. So anytime you use a script file, or you would use a script file anytime you're writing code that you want to duplicate again later, which is what makes MATLAB so useful, is that you can write code to compute a bunch of things and then come back and do the exact same thing again. Or you can alter it slightly with, say, different variable values and such. So that's basically that. And this, once again, you've been writing script files for every single homework you've done. All your template files are script files. So this shouldn't be anything super difficult, at least for now, hopefully not. So the next assignment we learned after that, or the next module we learned after that, was arrays. And for an array, you can store many items in a single variable, and they can be one-dimensional, two-dimensional, or higher dimensional, although that's not as common. A key element of arrays is indexing. So if you want to access only a specific value of an array, you can index such like that. So you can either, if you want to access the second element counting down the columns first, or any number of them. In addition to linear indexing, we also have row and column indexing, which you probably use more often anyways, and that is just the same thing. Row first, column second. And yeah, you can access any number of rows and columns at the same time using the concatenation as seen in the example with a first and third row, second column there. Some other useful commands that with dealing with arrays, at least that we used in that first homework or the second homework, was the command repmat, which will replicate or repeat a matrix in a specified number of times in the row-wise and column-wise directions. So try out these two commands with repmat A using 2 and 1 and 1 and 2 to see the difference and how those works. Another key concept from this module was the difference between matrix operations and element by element operations. So here, if we have a matrix A that I defined it as 3 rows, 2 columns. You can do matrix multiplication between A and A transpose, or A transpose times A. Those both work. But for example, A times A will not, because the dimensions don't match. There's also the element by element operations, which are slightly different. So that would be what I define as F here, as well as G, which are element by element operations. And those are things that we've been using a lot. So of course we talked about how the matrix operations are, so matrix multiplication is something that is defined by taking the dot product of each row of the first matrix with each column of the second matrix, whereas the element by element is just multiplying each element. And for those ones, they don't need matching dimensions like we did in matrix multiplication, where the number of columns in the first one must match the number of rows in the second one. For element by element operations, the dimensions of both matrices must be identical. So the next thing we learned about was relational operators. The primary ones are the equals, the not equals, the less than equal to, greater than equal to. We also made a lot of use of the and ors, both the array and ors and the short circuit and ors. So an example of this would be if you have the arrays A and B, as I defined here, 1, 2, 3, 4, and 1, 2, 4, 3. If you say A equals B, you would get back an array of trues and falses, which would say true, true, false, false, indicating that the first 2 elements of A and B are equal, while the third and fourth are not. Another useful command we learned is equal, which compares the whole array at once. So this, rather than giving you back an array of trues and falses, it gives you back a single true or false, meaning that the entirety of the 2 arrays are equal or not. And remember, you can always add a tilde for a negation. So you say not is equal A, B is the same thing as saying are they not equal. And then, of course, you can combine comparisons here. So you can say A equals B and B greater than 1. So that would give you just a single true value in the second element, because A and B are equal in the first 2 elements, and B is greater than 1 in the second element of those 2, whereas in the third and fourth elements, A and B are not equal to each other. And of course, we can make, using ands and ors, we can get some pretty, we can go on to build some more complex things. And here's some demonstration of how the OR works. Is A not equal to B, or B is 2. That should return, I believe, three ones in the last 3 elements. Another useful command is find, which will return the index values of the array where the given criteria is true. So when you type B equals 3, it's going to give you an array of logicals, and then the find command will take that array of logicals and return the index values of where those are equal to true. And you can also remember have index values being single, or you can do row and column indexes using 2 output arguments for the find command. And in the homework we went into some more complex things, and here's a little bit more. We have checking to see a comparison, checking to see if A and B are not equal, and if there is only one element of B that is equal to 2. So yeah, these are the main concepts from that lab. And then you can also, as I said, you can store the results of any comparison in an array. So where I said IDX equals A less than or equal to 3, that will store in IDX an array of logicals, which all represent true or false for the given condition. And then again, you can use those outputs to subset the original array or any other array with that output. So the next thing we learned about was conditional operators. The main ones here were the if-else and the switch case. And rather than going on about a long explanation, I'd rather just give you a simple example here. So this little block of code demonstrates how an if, else, end works. Remember, you don't need an else if. You can have for any if statement, you can have any number, including 0 else ifs conditions, but only one else condition. And remember that the order in which it checks, it'll check the if statement first, and if that one is true, it will go through, it will execute the code under that block and then skip straight to end after that is done. It won't check any of the else if conditions. So if, for example, if your else if condition was if A is greater than 0, even if A is equal to 1, so if A is equal to 1, it'll come down and it'll say A is 1, because that is the code there, and then it won't, even though the second condition under the else if is satisfied, it won't actually execute that code because it already satisfied the first if condition. And then again, else is what happens if none of the conditions are met. So go through this block of code with A defined as 1 or 2 or 3 and see what happens, and then that should demonstrate how those work. The same goes for switch case. So in this case, I had the variable A again defined as either 1, 2, or 3. So the way that works is switch A, and then the cases where we're accommodating for A is that A is either 1 or 2 or 3. And this implicitly checks if A is equal to 1 and if A is equal to 2, and etc. So you don't need to do any actual comparisons because the comparisons are done for you. So if A is equal to 1, then it'll go into case 1. And if A is equal to 2, then it'll go into case 2, etc. So that's about all I had for the conditional operators. The next thing we learned about was loops. Both for loops and while loops, or as we call them, definite loops and indefinite loops, because for a for loop, we have a definite number of times that we are going to execute the code, whereas a while loop is a little bit different, where we use a conditional, or we use a relational operator or some conditional statement to check if that conditional statement is true, and then if it is, we execute another iteration of the while loop. And we keep executing until that condition is false. which here is where a lot of times we end up getting, if you make an error, you might get stuck into an infinite loop. If, say, for example, you set some counter variable to be 0, and you say, well, counter is less than such and such, but say, for example, you forget to add to your counter inside the iterations, the loop will go on forever until you stop it. So that's something to look out for. And so here's a simple example of a for loop. So for I equals 1 to 10, you just display I, and if you run that code, you'll see it checks, it will just display the values 1 through 10, because I will take on, in the first iteration, I will take on the value 1, the second iteration it'll take on the value 2, and so on until 10, which is the last one. An example of a while loop demonstrating something similar is if you initialize I to be 1, and then say while I is less than 10, you go and you do the code block, and in here I just have something simple, which is I equals 2 times I, so it doubles in value every time. Now if you notice, if you pay attention here, close attention here, it'll start at 1, and then the first time through, it will multiply I by 2 and display it, so that'll display a value of 2. Now it won't display a value of 1 because before you get to the command disp, I has already changed to 2. And then the next time 4, and then the next time 8. And then notice how on the next iteration I becomes 16, but it still executes that loop iteration because it checks the condition before it enters the next iteration. So when I is equal to 8, it will still enter the loop because the condition for the while loop is still true, and then only after executing the next iteration does the condition become not true. So it will in fact display the value 16, but not, say, 32, because 16 is in fact greater than 10. So after that, we had a few homework assignments where we introduced the concept of functions. And functions are one of the most useful elements of programming in that it allows you to take any chunk of code you have and modularize it. So if you have, say you have a long calculation or a long code where you have, several, up to 50, 100 lines of code where you're computing a bunch of complex things, you can, what we call, modularize it and take parts of the code and make it into functions. Now, each function is specified with outputs and inputs in the file for which you create the function. And the inputs, once again, are defined on the declaration line, as are the outputs. And a few things to remember about functions is that every function must have its own M file, with the exception being local functions or subfunctions, which are treated a little bit differently and can only be called from inside the main function for the file in which it is saved. Of course, with the exception being if you use that function to return a function handle to the subfunction, as we did in one of the homeworks. Yeah, so hopefully functions shouldn't be too confusing to you guys because you've been writing functions in every single homework since this one, so you shouldn't need a lot of review. Another thing that we learned about were function handles, where you can define a function handle as an access to the function. So you can say, if I wanted to have a function handle for x squared times sine of 2 pi x, that would be the line I use. And keep in mind that for generality, depending on what you want to do, it's often useful to have your functions vectorized, which means it can handle element by element operations. So if you define this function and give it an array of x values, it will return an array of answers. And yeah, and you guys have had lots of practice with these, so hopefully these aren't still giving you much trouble. Yeah. So that's about the end of what I had prepared for today, or for this session. Like I said, there wasn't a lot because all of these things are things that you guys have been doing. We introduced them to you at the beginning, and then you've been using all of these concepts in just about every homework you've had so far, where you can see, you very commonly define arrays and check their values, as well as use loops and other things. So, are there any questions about anything so far that I've talked about? Okay, so it seems like no. So this is then, I guess this will be the end of the review session. We'll have another one tomorrow at 11 o'clock going over handle graphics, cells, and structs, as well as object-oriented. And as I mentioned, the next several review sessions will have fewer modules each, because those were ones with a little bit more tricky concepts and things worth spending more time reviewing. So if there's no questions, we'll end, and I'll see you guys tomorrow.